A very good morning to all my dear students. So in the previous video we have completed the theorems. Okay, perpendicular from the center bisect the chord. This theorem and its converse was proved. Now we are going to start exercise 10.3, in which the first question says that you have to draw the pair of circles and you have to find how many points are in common and what is the maximum number of common points. So that is your homework. You have to draw it by yourself. Okay, so now we'll proceed further to question number 2, which is you have to give the steps of construction, or you can say is construction, to find the center of a circle. That means you are given a circle, okay, but its center is not known, so you have to find out its center. So what are the steps that we'll go through? So first of all, you have to draw a circle with given radius. Okay, so you have to draw a circle, whatever radius you want to take, you can take, because it is not given in the question. 3, 4, 5, anything centimeters. Then you have to draw two chords. Let them say AB and CD. So you have to draw two chords AB and CD in the circle. Okay, and anywhere you can draw. Just make sure they are not exactly opposite, because then the perpendicular bisector will become a straight line. So it's better you can draw two chords anywhere on the circle. So you have to draw this one. Then we'll proceed further, and then the next step is you have to draw the perpendicular bisectors of the chords AB and CD. That means you have to draw perpendicular bisector of AB and perpendicular bisector of CD. So we'll do this now. So now you know how to draw the perpendicular bisector. So what you have to do, you have to keep the center over here and you have to keep the radius which is greater than half of this. Okay, so half of the chord से ज़्यादा आपको लेना है. You have to mark an arc over here and one arc you will mark over here, and then without changing the radius from the other side also you have to mark the arc. Okay, so as you can see we have drawn two arcs. Okay, so we are going to draw the perpendicular bisector. Now what you have to do, you have to join these two. So you can just join them using the dotted line. Okay, so this is the first perpendicular bisector. This is the perpendicular bisector of AB. Now similarly you will draw the perpendicular bisector of CD. तो उसमें भी आपको हाफ से ज़्यादा रेडियस लेना है, and then you have to mark an arc. Okay, so this is the first arc, and then from the other side you will mark another arc. So you will just increase this arc, and this one is this. Now you can see these are the 2 points, so you will just join them. Okay, so you have to join these two. So you can see I have drawn the perpendicular bisectors of both the chords AB, which is this one, and CD, which is this one. Now the next step is these perpendicular bisectors will meet at a point. So let that point be O. So this is the center of the circle. Okay, so that means the perpendicular bisectors of any two chords on the circle gives us the center. So this is second question. Now we'll see the next question. Okay, so this is our next question, question number 3. Now I have done the construction with the help of a pen just to make sure that the diagrams are clear to you. But please make sure whatever diagrams you are making, use only pencil, ruler and divider or compass, whatever you want. Okay, but only pencil. Now it is given that two circles intersecting each other at 2 points. So this is point P and this is point Q. Okay, this is point P, this is point Q. So two circles are intersecting each other at these 2 points, and you have to prove that their centers lie on the perpendicular bisector of the common chord. This is the statement of the question. Okay, so basically PQ, when you will join, it will become the common chord for both the circles, and you have to prove that the centers O and O dash lie on this perpendicular bisector. So you know O is the center of circle, O dash is the center of circle, so you have to join it. Then we have to prove that O dash, this straight line, is perpendicular bisector of PQ. So perpendicular bisector of PQ means they are making an angle of 90 degree. first thing, and second thing that these two parts are equal. So for this the construction will be, you will have to join, okay, all the sides, so that this is the construction. You have to join the common points with the centers. Now you can see the diagram. So now we'll prove. Now in triangle POO dash and QOO dash, that means the upper triangle and the lower triangle. So in these two triangles, OP is equal to OQ and PO dash is equal to QO dash. These two. Reason will be radii of same circle. Okay, these two are radii of same circle and these two are radii of same circle. Okay, and OO dash is common. This side is common. Therefore, these two triangles are congruent by side angle side. And if these two are congruent, you can write that POO dash is equal to this one angle QOO dash. अब आपने करना क्या है? You have to take these two triangles. Okay. So when you will take POR and QOR, okay, POR and QOR. So in these two triangles, OP is equal to OQ, radii of same circle. Okay, I hope you can see the circle. Then angle POR is equal to QOR. We have proved in the first part, this one. And OR is equal to OR. This is OR is equal to OR common. So these two triangles also become congruent. And when these two triangles are congruent, you can write that this side is equal to this side. CPCT. Okay, PR is equal to QR. Give this equation number 1. And then you can write this angle is equal to this angle. PRO is equal to QRO. Okay. So PRO is equal to QRO. This is also CPCT. But since this is a straight line, these two angles are making a linear pair. So their sum will be 180 degree. And since both the angles are equal, each angle will become 90 degree. Okay. So you have proved that these two angles are 90 degree and these two parts are equal. That means OO dash is the perpendicular bisector of OQ. So this is all what we wanted to prove. So we have proved this one. Okay, so you can write from 1 and 2, OO dash is perpendicular bisector of PQ. So this way, please complete exercise 10.3.